Hi everyone, we are learning a few different techniques for evaluating limits analytically today. So the first one that we have is the limit as x approaches 4 of something with a square root. Oh my gosh, okay, looks super complicated, right? So if I plug in 4, which is again the first thing you should always do, you'll get 1 minus 1 on top, and then 4 minus 4 on bottom, so you get 0, 0 over 0. So that's again called indeterminate form. And that just means there's something else we need to try. Right, so a lot of times when you have a square root, especially if it's in the numerator, we will rationalize. So we will multiply by the conjugate. And we're going to rationalize the numerator in this case. So what I mean by that is I'm going to multiply by the square root of x minus 3 plus 1, top and bottom. Okay, what I'm going to get is the limit as x approaches 4 of, now over here, the square roots are going to cancel. So I'm just going to have x minus 3 minus 1. Okay, on bottom, I'm going to keep everything separate. Do not combine these. It will just make your life harder. Okay, a little bit of simplification. I have the limit as x approaches 4 of x minus 4 over x minus 4 times the square root of x minus 3 plus 1. Oh, look at that. It looks like something cancels. Imagine that. Fantastic. And that's primarily what you'll be looking for, is you'll be looking to cancel out whatever is causing you problems. Right, so in this case, because my limit was approaching 4, x minus 4 was a bad thing for me, especially if it was in the denominator. Right? If it's just in the numerator, it's fine. Right? But x minus 4 is really bad for me to have in the denominator because that means I'll be dividing by 0. So whatever I can do to cancel that out, I'm going to do in order to solve this problem. Right? And that would mean getting an x minus 4 in the numerator. In this case, I could do that by multiplying by the conjugate. Okay. So now that I've gotten rid of that problem, if I just plug in 4, I'll end up getting 1/5. So a much better answer than 0 over 0. Alright, next I have a complex fraction. Alright, so crazy. When I have fractions like this, it's typically a good idea to combine them, so get a common denominator. That's not how you spell common. Get a common denominator. Right, so we could divide the x first, or we could combine my numerator first. It doesn't really matter. I think it's a little bit easier to combine first. So I'm going to get a common denominator first. So I'm going to have 1 over 2 times x plus 2 minus 1 over 2 times x plus 2. That's not true. Sorry, 2 over 2 over x plus 2. And then x plus 2 over 2 times x plus 2. Alright. Now we're in business. Alright, so I'm going to combine these. And I will have a negative x over 2 times x plus 2 over x, and all of this as the limit as x approaches 0. Okay, so the nice thing is, again, I'm trying to cancel what is causing problems for me, and in this case it's this big ol' x in my denominator. And now I have an x in the numerator. If you don't see that these cancel, we can rewrite this as the limit as x approaches 0 of negative x over 2 times x plus 2 times 1 over x. Remember, dividing is the same as multiplying by the reciprocal. Right, so my x's will cancel. I end up with the limit as x approaches 0 of negative 1 over 2x plus 4. And now if I plug in 0, I see I just get negative 1/4. Alright, and my next example, this is definitely a situation where I'm going to factor. If you do not remember how to do cubes and you didn't look it up from the last notes, hey, remember SOAP? It's same, opposite, always positive. Right, so if I have 2 cubes, a and b, then I'm going to have a plus b times a squared. So first, my sign is the same. Second sign is opposite. The last sign is always positive. Right, same thing here. So it would be a minus b, a squared plus ab, so same and then opposite, and then always positive. So the big difference here is that I do not have a 2ab in the middle. That's the difference between, that's the big difference to me at least between cubes and squares. Right, so I'm just going to factor this. I have the limit as x approaches -1 of x cubed plus 1. So that would be x plus 1, x squared minus x plus 1 squared, all over x plus 1. Alright, these cancel, and again, that's what I wanted because that's what's causing me problems. So I have the limit as x approaches -1 of x squared minus x plus 1. Now if I plug in -1, I'll have 1 plus 1 plus 1. So 3. Alright, and moving on to the last problem. And you can ignore all this. Alright, in this case, we're just going to do some algebraic simplification. So we're just going to simplify. Alright, easy peasy. Something you may not have seen before is that we have x's and delta x's in the same problem. So note what your variable actually is. In this case, my variable is delta x, not x. My variable is delta x. Big difference. Okay. So if I plug in 0 for just delta x, right, let's see what happens. So I'll have 3 times x plus 0 minus 3x over 0. Okay, so I still have my x's here. I have 3x minus 3x, so I'll get 0 over 0, right? So that does tell me that I have indeterminate form. So what I'm going to do is just distribute, see what happens. So I have my limit as delta x approaches 0 of 3x plus 3 delta x minus 3x over delta x. Okay, my 3x's cancel. Totally fine. I end up with the limit as delta x approaches 0 of 3 delta x over delta x. Okay, so these cancel. So I know that there's a delta here and it might look scary, but just keep in mind that this whole thing as a unit is your variable. These cancel. So I have the limit as delta x approaches 0 of 3. I have no delta x's to plug a 0 in, so my answer is just 3. Alright, in terms of your homework, that's it for these notes. Your worksheet is actually past the next set of notes. You can get started on this. It's not due until after we've done the next set of notes, okay? But you can get started on this. There are problems in here you may not know how to do yet, but there are definitely problems in here that you do know how to do. So go ahead and start working on this. It's kind of long, so give these a shot. If you have any questions, let me know. And that's it for me. Have a great rest of your day.